this video, we will be deriving van der Waals equation of state. What is an equation of state? An equation of state is a thermodynamic equation relating the variables that describe the physical state of a system under given conditions. Examples of these variables include pressure, volume, temperature, etc. One example of an equation of state is the ideal gas equation. Looking at the ideal gas equation will help us derive van der Waals equation of state. The ideal gas equation is defined by PV equals nRT. Each variable has specific meaning here, where P is the pressure, V is the volume, N the number of moles of gas, and R the universal gas constant, and T the temperature.
The ideal gas equation only works in scenarios where the temperature is very high and the pressure is very low. Okay, so this is the ideal situation. In this ideal situation, we have very low pressure. And low pressure means that the total volume of the gas is extremely big compared to the volume of individual molecules in that gas. This allows us to assume that the gas molecules are infinitesimally small points that take up no space. So all of these molecules have no volume. In this ideal situation, we also have high temperature. This means that the gas molecules are moving at very high speeds, and this allows us to assume that they zoom past each other without feeling any form of attraction. So all of these molecules don't feel any force between each other. These two conditions, are what make an ideal gas. In more real scenarios where the pressure isn't that low and the temperature isn't that high, this gas model starts to break down. And in this situation, we must modify the ideal gas equation to make it work for real gases. And this is where the van der Waals equation of state comes in.
There are two modifications we make to the ideal gas equation in order to derive the van der Waals or real gas equation. The first modification removes the assumption that the gas molecules have a negligible size. Looking at the animation, we can see that the molecules take up a finite space. So the total volume of the real gas includes the volume of the ideal gas plus the total volume that the molecules take up. We can see this in the equation V real is equal to V ideal plus Bn, where n is the number of moles and B is the volume for 1 mole of a particular gas.
The second modification removes the assumption that the gas molecules don't feel any attraction towards each other. This means that the outer gas molecules are more attracted to the inner gas molecules, which then means that they collide with the Waals container much less frequently. In this diagram, we have molecules of gas within a container, with the van der Waals forces between them shown in green. For simplicity, only the forces between particles which are close together are drawn. If we now take a closer look at a molecule close to the edge of the container, we see that the net force of attraction will act towards the centre. This results in fewer collisions per second with the container walls, which therefore reduces the pressure within the container. Looking again at our diagram, if we now investigate the net force acting upon a more centrally located particle, we see that the van der Waals forces act equally in all directions. In general, the net force is now 0. With the knowledge that P real will be less than P ideal, we can now make the second modification. We can show this by writing P real equals P ideal minus a constant A times n over v squared. The constant A just represents the strength of interaction between the two molecules. N over v represents the concentration of the molecules. So why do we have this concentration of the molecules squared? Thinking about this in terms of the number of molecules, the number of collisions is going to be proportional to the number of molecules squared. The concentration is effectively the number of molecules per unit volume, so n over v squared measures the frequency of close encounters between each molecule. Substituting equations 1 and 2 into the ideal gas equation, we get P ideal minus A times n over v squared, all times by V ideal plus Bn, which equals to nRT. This is the van der Waals equation of state, which works for both real gases and ideal gases.